Hello, I am Anthony Willis, the CEO of Innovation Consultancy, a small tech startup that creates digital products for Caribbean students with a focus on CXC mathematics and English. Our innovation won the Guyana Innovation Prize in 2023 for integrating ICT in education. Now listen to the I-Analysis deep dive into the crisis in math.
We've been given this fascinating stack of source material. It's a whole proposal, really, for a suite of digital products. And they're designed to perform, well, a kind of surgical intervention on a very specific challenge, the failure rates in the CXC math syllabus.
Okay, so let's unpack this right away because the sources they're very clear. The ambition here is not small. It's not just tutoring. We're talking about a total systemic shift in how mathematics is taught and learned. They're betting everything on blended learning and the flipped classroom model.
And that's exactly where we have to start. This deep dive is really about the architecture of learning itself. How do you take a subject where students are, statistically failing in huge numbers and transform the whole process from just passive absorption, sitting in a classroom, listening into an active, repeatable, skill-building exercise? The core philosophy here, it drives absolutely everything. And that foundational premise is maybe the most important psychological shift a learner can make. Math, they say, is explicitly a skill. It is not an innate talent.
Right. Think about what that means. If you think math is a talent and you fail, you think, I'm just not smart enough. But if it's a skill, a failure just means I haven't practiced the right steps enough yet. It completely changes your emotional response.
That shift, from a fixed mindset to a growth mindset, that's revolutionary in an education system. And they connect that philosophy directly to what they call the most important skill of the 21st century, which is learning how to learn. So this isn't just teaching trigonometry, it's teaching metacognition.
Precisely. And if you're aiming to teach students how to manage their own learning, the tools you give them have to be adaptive and accessible, which takes us right into the scope of the material. It promises full, comprehensive coverage of the 10 major topics on the CXC math syllabus, and is all aligned with the official school curriculum.
But alignment alone isn't enough, not when you're dealing with huge practical limitations. And here's a detail, a critical infrastructure detail that just speaks volumes about the project's goals for accessibility. The resources are engineered to be delivered on a simple flash drive.
That's huge. It really is. We always talk about digital learning like it needs perfect broadband, perfect Wi-Fi, but this system just bypasses the digital divide completely. For a student with, say, unreliable internet, that flash drive makes the flipped classroom model a functional reality, not just some ideal. The content's there anytime.
Okay, so now we get to the core of the problem they're trying to solve. The material doesn't just, cover everything broadly. It does a forensic analysis of where students are actually failing. It zeroes in on what they call the hard topics in the CXC exam, specifically paper 2, the optional section, where each question is worth a massive 15 marks.
And this is the data point that should shock everyone. It validates the whole intervention. The sources cite a statistic that really sets the stakes. 90% of students achieve a mean mark of only 3.5 out of those possible 15 marks.
Wait, 3.5 out of 15?
Out of 15.
90% of them. That's not just a failure, that's a catastrophic statistical breakdown.
It is. And the material says, rightly, that scoring that low guarantees failure. It doesn't matter how well you do on the rest of the exam. It shows a systemic failure to teach the application, the synthesis that those harder questions demand. So the intervention can't be broad. It has to be laser focused on those specific topics.
So just to be crystal clear on the target here, the proposal names 4 specific areas that they're just overloading with strategic content. It's trigonometry, relations and functions, vectors and matrices, and circle theorems. That clarity, that focus is the foundation for the entire thing. Okay, so given how serious the stakes are with those hard topics, you have to ask, how does the teaching methodology actually change? How do you keep students engaged and practicing? Which brings us to the flipped classroom model.
The flip is key. In a traditional classroom, right, the teacher lectures and then assigns the hard problems for homework.
Which leads to frustration, kids just copying answers.
Yeah, the flip reverses that. The lecture, the content consumption happens at home. And that's where these short, high-quality videos come in.
Right, they detail a pretty substantial video strategy. Bite-sized, short-form explainer tutorials, 5 to 10 minutes each. And they're promising a huge volume, like 20 to 30 videos for every major topic. But how does just shortening a lecture video actually count as a flip?
Because the short length allows the content to be structured around the 5 E's pedagogical framework. So engage, explore, expand, elaborate, and evaluate. This isn't just watching a shorter lecture. It's a dynamic cycle built right into the digital resource.
Okay, let's break that down for, for anyone listening. What do the 5 E's actually look like for the student?
So think of it like this. The engage part. It hooks the student with a real-world problem. Then explore gives them the tools and the concepts to start working on it.
Right.
Expand and elaborate. That's where they see the principles applied to more complex problems with step-by-step guidance. And then finally, evaluate forces them to test their own understanding right then and there. It's a full multisensory learning experience.
And the beauty of that digital delivery is the control element. The videos are short, designed for, modern attention spans, so the student controls the pace. They can pause, rewind, rewatch a 30-second explanation of a formula 5 times if they need to, without holding up a whole class.
And that sense of agency, that power to manage your own learning, it's psychologically empowering. It changes the dynamic from being lectured at to sort of collaborating with the material.
And crucially, they don't just stop with the formal content on the flash drive. They're meeting students where they already are with a dedicated mobile strategy. This means super short-form videos, 1 to 5 minutes, for platforms like TikTok, YouTube Shorts, and Instagram Reels.
That's smart marketing for sure, but it's also just sound pedagogy. Students are on their smartphones and tablets for learning anyway. This just makes the content perfectly snackable. It gives them quick conceptual reinforcements or a little motivational boost during their day.
Now, as we move into the strategic section, I noticed something. The proposal is heavily weighted toward analyzing and correcting mistakes. It feels less about just teaching new content and more about teaching students how to stop failing. That seems like a critical distinction.
It absolutely is. I mean, if you truly believe math is a skill, then any failure is just diagnostic feedback. It's data. So the strategy shifts from just teaching content cold to giving students the tools to self-diagnose and fix their own errors. And this is where the whole error analysis component becomes the central pillar of the system.
And they support this with a library of customized infographics. It's not just about making things colorful, it's designed to dismantle strategic barriers. We're seeing materials that address the specific pain points Caribbean students face in CXC mathematics, with real ways to get past those common hurdles.
And they complement that with tools like the error analysis of the most common mistakes students make in Paper 2.
This is so powerful because it takes the guessing out of studying. Instead of just practicing blindly, a student knows exactly what kind of trap the exam is setting and how to spot it. They also talk about replacing mechanical routines and haphazard approaches with science-backed problem-solving strategies. That sounds a bit corporate, but what does it actually mean for a student sitting at their desk?
It means swapping out random guessing or just general panic for a specific proven mental map. These strategies give them repeatable, systematic steps that researchers know work under pressure, especially on those tough, multi-step problems you find in, say, vectors and matrices.
And giving a student a structured, repeatable process, that has to be the key to reducing that debilitating math anxiety. If you know step 1, step 2, step 3, you're just less likely to freeze up.
Exactly. Anxiety comes from a feeling of having no control. So by providing 6 science-backed learning strategies and showing them precisely the common mistakes made on those infamous hard topics, trigonometry, functions, vectors, and circle theorems, they're giving the student back that control. They're building confidence through structure. They even offer specific guidance on how to avoid those pitfalls under exam conditions. That's a focus on test-taking strategy itself, which is so often neglected in a standard curriculum.
And for the ultimate proof, the product listing includes video-based step-by-step reviews of past CXC exam papers. That's the critical bridge, right? It shows the learner how the strategy and the content translate directly into a successful exam. It validates everything. All right, let's move on to section 4 and look at assessment, because it's clearly not just about giving a grade, it's engineered to fuel motivation.
The immediate feedback loop is the engine of motivation. That's the whole idea. Using mobile apps for quizzes means the learner gets an instant score and immediate, detailed feedback. You contrast that with waiting a week for a teacher to grade a test. That delay just kills momentum. Instant feedback keeps you going. The question design is also very deliberate. They use both LOTS and HODICAS, that's lower order and higher order thinking skills, and they focus intensely on those hard topics in Paper 2.
So LATS would be like recall questions, testing your knowledge, while HOTS are application, analysis, synthesis, the kind of questions that require real strategic thinking. That makes sure the student isn't just memorizing formulas but can actually apply them. And to make all this high-stakes practice engaging, they use gamification, which takes the form of these short, video-based, timed, multiple-choice quizzes, still focused on the hard stuff. The timed element simulates pressure, but the video delivery makes it feel more like an interactive challenge than a test.
And while the dynamic apps drive that immediate practice, they back it all up with a massive, robust, print-ready library. This is the comprehensive set of PDF resources for all 10 of the major math categories.
That print-ready library, that ensures the resource can be used both digitally and physically. It reinforces the whole blended learning idea. And we saw that the PDFs aren't static. They're colorful, clickable, and fillable with lesson plans and detailed study guides. But I think the most valuable part here has to be the cheat sheets. These aren't just lists of formulas. They're described as strategic guides. They have specific notes on what to expect and what to avoid in the exams. It's basically an insider's view of how the test works.
Right. And to round out all the structural support, they even include specific mobile apps to help with the SBA, the school-based assessment. It just shows the commitment to covering every single component of the curriculum a learner needs to succeed. So this deep dive has really shown as a highly sophisticated pedagogical model, and it's all built on one core idea: math is a skill. By focusing on accessibility, using the flipped classroom model powered by the 5 E's, and critically placing intense focus on error analysis and strategy, this system tries to fix not just content gaps, but also the psychological barriers, like math anxiety, that hold students back.
So what does this all mean in the end? We've reviewed a highly structured, multi-format, data-driven approach. It's designed to address a statistically proven failure point in a very specific, high-stakes exam. By prioritizing strategy, flash drive accessibility, and immediate gamified feedback over just lecturing, this proposal is a blueprint for high-precision educational intervention.
It raises an important question, doesn't it? Given the clear, data-driven success this kind of architecture is designed to achieve in math, with the instant feedback, the error analysis, the bite-sized content, how quickly could we adapt this comprehensive approach to fix similar failure points in other complex subjects? I'm thinking of physics or even certain areas of the humanities. The methodology is solid. The question is, how universal is the blueprint? That's definitely something for you to mull over.
All right, class. So if we have sides A and B, how do we find C, the hypotenuse, using Pythagoras' theorem?